Finally, here's an example where we are going to use external data to train a deep learning model, and we will also make use of a GPU. So this example is based on the basics of musical instruments classification using machine learning. It's a series of tutorials that you find at Guitars AI GitHub, basics of musical instrument classification. And here we go through different techniques and methods to use machine learning to classify audio files that are recordings from different musical instruments. So we go through the MFCC, so the male frequency capture coefficients, the K nearest neighbors algorithms, the support vector machines. We look at the Keras library, both the model class and the sequential model. We take a look at the grid search technique, and we look at the short time Fourier transform, convolutional neural networks using Keras, and also using PyTorch. So here you find all the files, and the data we are going to use is taken part of the London Philharmonia dataset. There's a dataset with thousands of recordings of musical instruments. Here I selected some, just a few, and it's in this zip file here, and this is what we're going to do. So to run the example, you can go here in the GitHub, and there is launch on Colab, and we can launch this example, and it will open on Google Colab. This is quite an old tutorial, if I'm not mistaken. It's from 2018, and it's very common in Python, and especially if you are using, for example, Colab, that you have problems with libraries. So libraries are constantly being updated, and a lot of times these updates, they don't care about backwards compatibility. So you may have a perfectly running code, a library is updated, and then everything stops working. And we are going to see this happening in this Colab notebook, and we'll learn how to get over these problems and how to solve these problems. So we are going to use a GPU, so we can go here to runtime, change the runtime type, and use a GPU. We are saving now. As I mentioned, this is a node project, and it's using TensorFlow version 1 and Keras. At this time, Keras was supporting multiple backends, but since the release of Keras 2.3, this was the last release of multi-backend Keras, and now Keras moved under the umbrella of TensorFlow. So the developers, they are recommending that you switch from Keras to the TF Keras in TensorFlow 2. This is already a problem that we are going to face here, and we will try to do some changes to be able to run this notebook. Another problem is that Google Colab has its own environment, and they are updating the libraries as they wish, and they are installing the libraries that they think are useful. Sometimes you need to install an extra library. We've seen already how to do it. Sometimes we need to change the version of a library to keep compatible to the old code, for example. We've seen how to do it. And sometimes also we will need to change some things in the code. So let's start running the code and see the problems we will face. Running the cell, running the imports, and voila, we already faced the first problem. So no module named Keras backend TensorFlow backend. So let's see what we need to do. As I mentioned before, we need to use TensorFlow version 1, and we need to use the Keras was not part of the TensorFlow 2. So if we go back here to the GitHub repository, we take a look at this binder where we find the requirements of this project. We go to the environment, and we see that we are using Keras version 2.2.4 and TensorFlow 112. So what we're going to try to do is to change here this environment, installing these versions of the libraries. So here we can install this version of Keras using the pip install like we've seen before, and the runtimes tells us that the dispatches were previously imported and we need to restart the runtime in order to use this new installed version. So we start the runtime and we can try again, see what it will tell us now. Okay, so Keras there, but there is a problem now with TensorFlow. Cannot import the set random seed. Still didn't use the version of TensorFlow that this project was made. Let's try to install this version of TensorFlow. So now it's installing TensorFlow, uninstalling some previous installations, installing this version of TensorFlow 1.12. And once again, we need to restart the runtime so these changes are applied to this environment. And let's try again. So now it is importing everything. It seems there's some warning saying that things are being deprecated. So now we see that we are using the TensorFlow 112 and there is a GPU available for us, the Tesla T4. So let's see what happens when we continue to use the code running another cell, and now it is preparing our notebook. So it's cloning the GitHub repository where we have our data that is this zip file in the audio folder. So this is one of the ways that we can port external data to the Google Colab. Then it's unzipping, setting up everything. It's still saying that there's no GPU detected and we must configure the runtime, but it's inflating all the MP3 files, and it also gives us here details of the processor it's using. So there's still something missing that we need to configure. Unfortunately, I'm not able to install TensorFlow 1.12. There are other dependencies there. It's not working, so we need to change our strategy. So I'm going to factory reset the runtime. Also want to clear all outputs, so clean notebook. Then I will just check if I'm still using the GPU. And now there's one thing in Colab that it comes with a pre-installed version of TensorFlow 1, and with this magic command we can tell Google Colab to use this TensorFlow version. So we are running the cell. We also will use the TensorBoard Colab. Maybe it will not work because it's an old version, but just so we don't need to make changes here, as we are importing from TensorBoard Colab, we are importing here inside this try and except in Python. So if it will not find this library, it will stop executing and will not be inside of Colab, and then there will be problems in this execution. So I will just install this library as well. Then I'm installing the Keras 2.2.4. Here we check the TensorFlow version. So it's 1.15. So hopefully it will work without any changes. But if some function is deprecated, we will need to replace or remove. As we are using these old libraries, Colab can give us a lot of warnings, so I will try to import these warnings and ignore all the warnings, so our cells is not full of warnings of deprecated functions and things like this, as long as it's working. So let's try this. So now Let's go back and try to import everything what we need. It's using TensorFlow backend, and now it found a GPU. Before it was not finding a GPU, the Tesla T4. So we move on to configure things for Colab. You can also run this notebook locally, so this is why everything that is specifically related to Colab I included here. So if you're not, it tries to import Google Colab, and if it's not inside Google Colab, it will tell you that you are running locally, not execute this and break your code. But we are inside Colab, so finds here the GPU and gives some information about our Tesla T4, and it starts to clone the Git repository and unzip the zip file as I mentioned before. Take a while because some 100 MP3 files. Then it's done. So we have all our files. Next, I'm just defining some signal processing parameters. Here's an auxiliary function that I use to display a website inside of the Google Colab. Here now it will find all the audio files, here inside our audio folder, and then it will generate labels and get the duration of these audio files. So this is what it's doing. It's getting Oboe MP3. So this is from the London Philharmonia dataset that you can find some information about it here, the README of hub. So while it's still calculating the duration and loading all these files. Oh, the London Philharmonia page is not available anymore. Oh, so they just changed here. It's on resources sound sample and not in explore sound samples anymore. So I can here and fix this really fast while we wait for the files to be loaded. Changes up to date. So here you see it, download thousands of free sound samples recorded by Philharmonia musicians, and it's done. So now it calculated what's the maximum duration, the minimum duration, and the average duration of all the files. This way we can, for example, shorten some files or pad some other files if we want to use the same number of samples for each audio file. There are different techniques on how we can handle files that they have different durations. So this is what I'm doing now. I will trim the silence from these audio files and recalculate the duration. Take some more time. It's done calculating the duration. So far the code is running smoothly. I will not go into the details on this tutorial because if you go to the GitHub, there's a complete YouTube playlist where I go through the theory and practice on these basics of musical instruments classification, and I explain the code, I explain the theory. Here we just running the code to see it's possible to run in Google Colab just by doing these modifications, as it is an old tutorial using libraries that had many functions that have been deprecated. So here we have the distribution of the duration of the files. Now there is a little explanation of the short time Fourier transform, and this is the feature that we are going to use for the classification. So here is just an example of the spectrogram. So this is a musical instrument, and this is the spectrogram, the STFT spectrogram from this oboe. Then we will encode labels for classification. So we have 6 classes: the cello, flute, oboe, sax, trumpet, and a viola. Then we will split our data set into train and test set. Here a short explanation about convolutional networks, and here we are creating our convolutional networks model using Keras, and there's Tensorflow as a backend. So here is our model. There are many layers with max pooling, dropout, and dense layers in the end. So I explained this on this in detail in this YouTube playlist. We define our loss function, our optimizer. Then we defined our feature generator that will compute the short time Fourier transform for all the audio files, and then it will start to train the model. So far everything is running smoothly. Everything looks that we just needed to have the correct versions of TensorFlow and Keras, but we have a problem at this point here. We continue debugging this notebook, make it work in Google Colab. It's a very old notebook. Things have changed a lot of libraries in terms of Colab, so we change the strategy once more. So what happens is that not only we need to install an older version of TensorFlow, but also an older version of Cuda library. So we will install Cuda 9. This is what we do with this cell here. It will download the Cuda and install. Take quite some time, and we'll try to install the TensorFlow, the 112, which is the same version that we used here, but now also with the Cuda library, the correct version, and we'll see what will happen next. So apparently Cuda 9 is installed, and now we move to install TensorFlow 1.12, and then we also need to install the Tensorflor-gpu 1.12, as we are using a GPU here. So at this point we have Tensorflor-gpu 112 installed, and we installed Keras like we did before. We installed Tensor board Colab, and here we have the TensorFlow 1.12 with Cuda 9 and Tensor-gpu. So let's start running the code again and see if now it will work. Using TensorFlow backend, it found GPU, keep things, downloading, cloning a repository, extracting files, defining signal processing, and so on, generating labels, stream silence, calculate the duration distribution, calculating the time Fourier, encoding labels, dividing the data set into training and test set, defining our model, the convolutional layers, defining loss function, the optimizer, and then we will reach the point where we'll try to train the model where we had problems last time. Until this point everything seems to be working fine. Now we'll try to train our model. Starting tensor board, separate page, it creates the link, starts with the first epoch. So we have a training set with 450 files. It seems to be working okay. Let's try to test the board with ngrok. So it's loading fine. Here we see our model, layers, convolutional layers, max pooling, dropout, dense layers. So this we have a tensor board running separate page. The old style of using tensor board. Now Google Colab also offers another way, kind of a magic function to use tensor board. This topic of another tutorial. The first epoch done. We can check on tensor board scalars. We already see here the training and validation, accuracies and loss. So tensor board seems to be working fine as well. Training seems to be working fine, and it will take quite some time. So I shorten the time of training just to things to move faster. So after 3 epochs, we have here the training was successfully accomplished. Also tensor board working. We can continue running the code and see we can also have our plots. Now we will try to evaluate the model, making the predictions and loading the best model what we got from our training, and then making the predictions with this loaded model. Also see that the best model was saved here. We can, for example, download this model and save into our computer. Have in mind that, as we've seen on the tutorial about Google Colab and external data, that everything that is locally in this Colab is not saved. So if you close this, you lose all the files unless you mount your drive and you save directly to your Google Drive, or you download to your machine. Otherwise you will not you will lose this file. So predictions be ready, working. We have our metrics, so evaluating model. Let's try to plot the confusion metrics. So far the code is running nicely. So model is working fine. Few wrong predicted files, just 5, and we reach the end of this notebook. So we've seen how to make the changes in the Google Colab environment so that we can run this old notebook. Is using a different version of Cuda, using a very old version of Tensorflow, even older than when you use this magic cell telling Google Colab to use Tensorflow version 1. It uses the 1.15, and here we are using the 1.12. So after all these modifications, we managed to run this notebook. And this code will be available at this GitHub. So I will save here as this introduction to convolutional neural networks using Keras. And when you press here launch on Colab, it will launch this notebook already with all these modifications. So that's it for this tutorial, and I see you next time.